Hello everyone, welcome back to Code with Cougar. In this video, we'll be talking about data types and abstract data types. We'll also be talking about user-defined data types. So let's get started and what basically a data type is. A data type is a classification system that is used in computer programming languages to specify the type of data that a variable can store or the type of data that can be used in an expression or the type of data that can be returned by a function. It helps the compiler basically to interpret and understand how to work with this data, how to perform operation on those data, and how to allocate a specific amount of memory for those data. So data types plays a crucial role in type checking and ensuring that the code is executed correctly and efficiently. So basically, data types defines the domain of values. It basically dedicates the range of values that can be stored in a variable or used in an expression. For example, in most programming languages, an integer data type can store whole numbers, while a floating data type can store only real numbers with decimal points. It also beside that, it also defines the operations that allowed on those values. So basically, the other use of data types are to determine the operations that can be performed on the values we store on in the variables. For instance, arithmetic operations like addition, subtraction, multiplication, and division are applicable on numeric data types like integer and floating points. On the other hand, string data types support operations like concatenation and stringing or extracting a part of a string from another from a given string. It also defines the amount of memory allocated for the data on how those data are stored in the memory. Different data types require different amount of memory to store their values. For example, an integer might require 4 bytes of memory, while in some programming languages, a floating point number might need 8 bytes of memory. So when we define a variable of type integer in most programming languages, so 4 bytes of memory will be allocated for that variable. So the data type also influences how the data is stored in memory, which affects the efficiency of operations and memory usage. So the memory allocation and storage method depends on the programming language and the underlying hardware architecture we are using. As we all know, variables can store data of different types, and different types can do different things. The most commonly built-in data types giving to us is integer. Integer data types used to store whole numbers, positive number, negative number, or zeros, and the operations allowed to be performed on these integer values or integer variables or addition, subtraction, multiplication, bitwise operation, and also ampersand operation. On the other hand, we have floating point types used to store floating point numbers with decimal points. For the floating point numbers, operations that are defined is addition, subtraction, multiplication. We cannot perform bitwise operation on floating point numbers, and also we cannot perform ampersand operation to get the remainder of two floating point numbers. Boolean is another type that we can give to our variables. They can store only true and false values. A string is also another type that we can give to our variables to store specific values like a series of characters and symbols. So now let's talk about user-defined data types or UDTs. They are basically data types that are created by programmers to extend the built-in data types that are already available in a programming language. So UDTs basically allows developer to create customized data types that better fits the requirement of a specific application, or also to use to improve code readability and maintainability. They are basically derived from existing data types. As I mentioned, UDTs are created by combining or extending the existing built-in data types provided by programming languages. We saw some of the data types such as Boolean data types, integer data types, floating point data types, string data types. We can combine them together to create our own user-defined data types. For example, you might create a user-defined data type to represent a complex number by combining two floating point numbers. Also, we can create our own data types to represent real world objects such as car or dog. A car might have a color, it might have a model, speed, etc. So we can combine the built-in data types to create our own car data type to represent an object car. Um, so the primary purpose of using data type is to allow the programmers to define their own data types that are tailored to a specific need, which can improve code organization and code readability. So we can basically define our own data type using either abstract or class. Abstract is basically a common example of user-defined data type that is a collection of variables of different type that are grouped together under a single name. So basically, abstracts allows programmers to create more complex data structures, but by combining the different built-in data types in a meaningful and organized way. For example, consider a program that manages information of an employee in a company. Instead of separately managing different variables for each employee, such as name, an employee might have a name which is of type string. An employee might have an age which is of type integer. An employee also may have salary. So for this example, let's give it a type integer also. So instead of storing the attributes of an employee in different variables, we can easily create our own complex data type called employee using extract and combine or group together all these attributes under a single name. So we can do extract using the extract keyword. We can create a structure and give our structure a name. We can give it emp or employee. Then inside these brackets, we can group all the built-in data types. For example, employee might have a string name. Is employee might have integer age. He might also have int salary. So as many as attributes we want, we can give to our own data type or complex data type EMP. So by creating an object or reference of this EMP, we can access each attribute and assign values to these attributes. So the next method to create our own user-defined data type is using a class. Basically, a class is a fundamental concept in object-oriented programming language. It serves as a blueprint for creating objects, which are instances of classes. A class basically defines a custom data type with its own attributes, also called a data member or properties. Same as extract, we can use classes to group together different data types, and also we can add functions to our class object or class data or our own data type using class. So basically, we can group together the attributes and functionalities that an object can provide using a class. Uh, Same way, like extract, we can use a class to group together attributes and also functionalities. Suppose we want to represent a car, so we can do class, use a keyword class and give it a name car. A car might have a string name. It might have a string make int speed. May have a string color. Also, we can define functions like void run. So it specifies how a car runs, or speed up void function speed up to increase the speed of the car. So beside uh, the attributes of an object, we can also group together the functionalities or the behaviors that an object has. So using a class keyword, we define our own data type, which is called car, and group together different built-in data types, and also we performed operations on those data types. So these are the two ways on how we can create our own custom data types using the different built-in data types to meet our needs. So now let's talk about abstract data types, or ADT. It's basically a high-level description of data structure that focuses on behavior and operation it supports, rather than the specific implementation details. By abstracting away the implementation, programmers can work with data structures based on their function. Next, we are going to talk about ADTs, or abstract data types. Basically, an abstract data type is a high-level description of a data structure that focuses on behavior and operation it supports, the data structure supports, rather than the specific implementation details of the data structure. So by abstracting away the implementation, programmers can work with data structure based on their functionalities without worrying how these data structures are basically implemented, how the memory management are handled, and how the data are stored behind the scene, uh, and what data structures are used to implement this specific ADT. So this making the code more flexible, modular, and easier to maintain. Basically, ADTs define the behavior and operations. An ADT is characterized by the operation it supports and the behavior it exhibits rather than the specific way it is implemented. It also describes set of data and options. An ADT basically provides a way to describe the data that this ADT or data structure can hold, and the operation that can be performed on this data without detailing how those data are stored or how the operations are implemented. Um, ADTs consist of two parts mainly: an interface, which describes supported operations and their inputs and outputs, and the implementation, which is the actual code that defines how the operations are carried out and how the data are stored. So this visual presentation shows how the ADTs are abstracted and how they hide the detail and provide only the functionalities. So suppose this is an abstract data type such as a stack or queue. We can abstract or group together all the functionalities and uh, properties of the ADT inside a class and only expose the public functions as an interface to the application or to the user. So the users can use this interface to operate on the ADT or abstract data types. Inside the ADT, we might use different data structure to implement our ADT. For example, we can use array to implement a stack, or we can use a linked list to implement a stack. We don't need to expose these implementation details to the outside user. So the outside user only needs the operations this ADT can perform without knowing how these operations are implemented and what data structures are used behind the scene and how data are stored in memory. So only the user needs what these abstract data types basically can do. For example, think of an stack ADT. The user only need to know that a stack can push a value, and also a stack can pop a value. We can use peek to see the top of the stack. We can check whether the stack is empty or full. So we don't need, as a user, we don't need to know how these options or functions are implemented basically. So this was a quick overview about data types and abstract data types and also user defined data types. Thank you guys for watching. Please don't forget to subscribe to Code with Cougar and see you in the next video. Bye bye.